In this video, I describe how we solved a no power in the Nest E thermostat problem for a 3-zone system. So I have 3 Nest E thermostats for a 3-zone system. However, the downstairs Nest thermostat continued to report that it had no power to support the battery.
The issue here is that the Nest E requires 24 volts in order to have its battery charged continually. The literature and technicians recommended snaking a third ground wire from the thermostat power source at the boiler
through the wall to the thermostat so that the ground wire would prevent any voltage drops that took place when the thermostat called for heat.
Rather than implementing what seemed like an ad hoc solution, we investigated why the thermostat was not receiving power during certain operations of the boiler. We discovered that the boiler configuration was pretty messed up, since the aquastat, which measured and controlled the internal boiler water temperature, was coupled to the downstairs thermostat, so that whenever the aquastat called for heat from the boiler, the Nest E thermostat voltage dropped to 0.
The old system had 3 zones, each with its own thermostat. 2 of the thermostats were connected to a Honeywell transformer relay box, which conveyed the 24 volts power to the thermostat while powering an independent circulator motor with 120 volts AC. The 3rd zone, the downstairs thermostat, was connected to a White Rogers aquastat, which, while including a transformer relay box to run the downstairs circulator, also controlled the gas valve on the boiler, calling for the boiler to fire up whenever the internal boiler water temperature fell below a set point, which in our case is 190 degrees Fahrenheit, as long as the downstairs thermostat was calling for heat. This, it turns out, was the sole connection between any thermostat and a gas valve. This means that if any of the unlinked thermostats were calling for heat, they would run their circulators that would try to call for hot water, but only cooler water would potentially be circulating through those zones because the downstairs thermostat was not calling for heat from the gas valve through the aquastat. So our plan was to decouple the downstairs Nest thermostat from the aquastat and use a TACO brand 3-zone switching relay to give equal weight to all of the thermostats so that they could call for heat independently, and the aquastat would only receive power when at least one of the 3 thermostats was calling for heat. The aquastat regulates the boiler water temperature through the gas valve. In this plan, we would repurpose one of the Honeywell transformer relays. It used to be set up to send power to a circulator when one of the thermostats called for heat. Now, whenever any Nest thermostat calls for heat, the TACO closes a relay, activating 24 volts at the Honeywell transformer, which then powers the aquastat, which interacts with the boiler to control the boiler water temperature, while the TACO switching relay is now controlling each of the circulators for the zones. In general, the function of an aquastat is to regulate boiler water temperature and to potentially run a circulator. For our solution, we cap off the 120 volt output of the aquastat, since we are not using the aquastat to drive a circulator. In addition, we short out the aquastat's 24 volt terminal that would normally have been fed by a thermostat. The aquastat regulates the boiler water temperature by sensing the water temperature and putting out 24 volts to the boiler gas valve whenever the boiler water temperature falls below a set point. As designed, the aquastat requires 120 volts in and transforms this down to 24 volts through its internal electronics.
We wanted to disengage our thermostat from our aquastat. What we're doing now is just detaching the wires that go from the transformer in the White Rogers main box that would have gone to the circulator for the downstairs. We are now disengaging those wires out of the transformer, and we're going to put those wires, reconnect them with BX into the new switching relay. So you may be wondering why we didn't hook up the 24-volt control output of the taco directly to the thermostat connection on the aquastat. Why did we use a Honeywell relay? Well, what I didn't mention earlier is that the aquastat was designed to accommodate the boiler's tankless domestic hot water heater. Long ago, before I owned the house, the tankless system had been disconnected and replaced with a separate domestic hot water heater and tank. So when the previous owners disconnected the tankless system, they kept the same aquastat and just dialed down the domestic hot water set point from 120 degrees to as low as it could possibly be set, which is 100 degrees. This meant that the aquastat was keeping the water in the boiler
at a minimum of
100 degrees at all time, which was really wasteful. So instead of buying a new aquastat that only has one set point for the boiler water temperature, we repurposed the existing aquastat
by shorting what would have been the thermostat input within the aquastat.
The aquastat always thinks there's a call for heat. However, we also set it up so that the aquastat
receives
its required 120 volts AC input only when one or more of the thermostats calls for heat. We achieved this control requirement by placing a Honeywell transformer relay,
which has a 24-volt thermostat terminal with
120 volts out between the switching relay box and the aquastat.
Hey, thanks for watching this video. It shows you how we solved the problem of having zero power to one of my Nest-E thermostats and how that caused a whole bunch of trouble in my boiler system. Please subscribe. CB99 videos.